by doing this problem that highlights the advantages of the second advantage of compartmentalization, increasing the local concentration. So here we need to calculate the concentration that can be achieved if we have 300,000 glucose molecules dissolved in 5 microliters of a solution in a test tube. And we need to compare this concentration with the concentration of glucose when the same number of glucose molecules are just in one bacterial cell that has that is shaped as a sphere with a diameter of 1 micrometer. So let's start by actually calculating the number of moles for those 300 glucose molecules. For that, we will use Avogadro number that relates molecules and moles. So we have number of molecules and we need to divide by the Avogadro number to get moles. And you know that you need to divide just by looking at the units of this constant, and since you need to have moles as an answer, the only position where you can put that Avogadro number is in the denominator. So that would be roughly 5 by 10 to the negative 19 moles. So that's our first step. Second step would be to actually determine the concentration in a test tube, right? So we have a volume of 5 microliter. We have that number of moles. So we know that the concentration would be that number of moles divided by the volume, and that would give us and 5 microliters means 10 to the minus 6 liters. So that would give us pretty much 1 by 10 to the minus 13 molar. Or we can say 0.1 picomolar, where pico stands for 10 to the negative 12. Next step is to determine the volume of that cell, right? So we have that cell with a diameter of 1 micrometer. And here we have the formula for the volume. The volume of a cell would be 4/3 multiplied by the constant pi and r cube. Now, we want to have a volume in liters. We have some metric unit, right? So we know that 1 micrometer is, I'm sorry. Back. 1 micrometer is 10 to the minus 6 meter. And we also know that 1 centimeter cube is 1 milliliter, which is 10 to the negative 3rd liter. So we need to convert everything into centimeters. So we need to go back here. And 1 meter is 10 to the 2nd centimeters. So we have 10 to the minus 4 centimeters corresponding to 1 micrometer. So now I'm going to plug those numbers in the formula. Don't forget that this is our diameter, which is twice the radius. So we need to divide 1 micrometer by 2. And let's convert it to centimeters right away, right? Using this equation that we derived right here. And again, that will look as if 3, right? So that will give us the, let's just round it up to 0.5 by 10 to the negative 12 cubic centimeters, which is milliliters. So if we want to convert into liters, that would be 5 by 10 to the minus 16 liters. So step number 4 is actually calculating concentration of glucose, of that number of glucose molecules in a cell. So we have the same number of moles, right? 5 by 10 minus 19 moles. over the volume, which is much smaller than the volume in a test tube, even though microliter volumes in a test tube is also very small, right? So we have 5 by 10 to the minus 16 liters, and that will give us 1 by 10 to the minus 3 molar or 1 millimolar, right? So we have 10 orders of magnitude higher concentration of glucose if we just shrink, if we just enclose those glucose molecules via compartmentalization in a cell. So this is an illustration of that advantage.